want to take you along the journey that we took in the matter of architecture. What Dick already said is an important part of how do you get AI, at least to our belief, AI into your operational process. I told you yesterday, we did this use case with Spotwell predictive analytics, and we set up this infrastructure that allows us to predict, are these Spotwells good or not? What for? Because by doing that, we can reduce the costs of the statistical quality process we are doing. So we have the task, reduce your costs. That's what we use this for. And we set up the data stream coming out of the devices into our server structures, visualizing it, training an algorithm, and then finally having an algorithm that gives us pretty good prediction on the quality of the Spotwell. Okay. But while doing that, and I told that yesterday as well, we figured out the problem is we only have very few not okay data points, because the technology is so well established and so well controlled that only once in a while you find a Spotwell that is not okay. So every time you have that, you retrain your model, because actually the not okay data points are the really valuable ones. Retraining the algorithm, and then comes what hindered us from getting this scaled out into production. How do we distribute these in the cloud trained algorithms into our factories? Once we have a new algorithm, we want to easily distribute this new algorithm into our plants so that we quickly switch from one algorithm to the other. First of all, letting the old algorithm run alongside with the new one, figure out, is the new one really better than the old one? And once we know that, switch it over. And that has to work in the way you would want to do this in a data center, just a couple of mouse clicks in order to orchestrate all that. Because if you don't do that, you spend a lot more money in people walking to all the PLCs, to all the control systems with a USB thumb drive and installing the new algorithms than you save for the quality inspection, then there's no reason in doing it. Yes, it's a cool thing to do, but operational-wise, there's no reason in doing that. And so what we did, the next step, what I want to take you into now, is actually trying to think the paradigms of automation anew. And the journey we went into is this journey. I want to actually invite you, all of you, to go down that exact same path, because I think this is actually going to be the future of automation. It's virtualizing automation on the shop floor. In the past, the paradigm of automation, at least for us, I'm not sure for you, but it's probably very similar if you're doing something with automation. The automation said, if I need a specific function, I buy a box that provides it, period. Which leads to factories like ours, where you have thousands of specialized boxes sitting around on the shop floor that do very specific tasks. And now you have all this compute power. For us, it's, I hope I have the number correctly, we have 45,000 IPCs distributed in our Ingolstadt plant, over 2.6 square kilometers. That's quite a big data center, actually. If you think those boxes stacked in a data center, that would be quite powerful. But we don't use it as a data center. We use it as for their local purposes in the process where we need it highly specialized. And what I want to encourage here is from automation to think a new paradigm. The paradigm, if I need a specific function, I buy a software providing it that runs on a virtualized, containerized, or whatever general purpose hardware. This is what we did in the data centers a decade ago and 1.5 decades ago. And the idea is why don't we go down the same road in our shop floor? Because if we do that, what do we gain? We gain an architecture that instead of really separating the field I/O buses, the shop floor hardware, and the data centers to a more generalized, standardized compute part where you still have some shop floor specific functions, but you have a universal compute way down in the shop floor. And this universal compute gives you the opportunity to deploy functions. So you can deploy an inferencing algorithm, you can deploy a security algorithm, you can deploy a visualization algorithm that tells the people working on the shop floor what they're supposed to do. All these functions where we right now use specific boxes for can be deployed on a generalized hardware. So what we have right now, this is a schematic sketch of how we set up our body and white shop today. We have robots, we have process devices connected to the robots, and then we have a field bus technology that through a switch, layer 2, layer 3 switch architecture connects to the PLCs, to the control PCs, to a plant PC, to a firewall that shields off this cell, and then from there goes into our production network. And our vision is that we can replace all of these boxes just by general compute. Just take general compute, industrial PCs into your cell, have all the functionality you need virtualized in, as I said, virtual machines, containers, whatever. And once you do that, first of all, you greatly reduce the number of boxes you have to take care of. You don't have to care for the security of every single one of those boxes, because through this virtualization layer, you can just do that standardized like you do in a data center on this compute. Second thing is, if you need more compute power because you have a more complex inferencing algorithm, you have a more complex whatever data algorithm that you need to run in order to do your operations, well then just add another compute. Just expand the hardware layer and integrate that into your compute virtualization, and you're done. That's the only thing you need to do. So once we do this on the shop floor in the body and white, we can also do things we did not need to do and we did not spend money on in being a car producer. But what you can do is, having 3 industrial PCs, you can think about doing fail-safe operations. If one of those PCs go down, you still have 2 more that keep up the load. This is something that probably the process industry would be much more interested than we are. But again, if you have something that helps your operations to be still up and running while one of those things go down, that might be helpful for us as well. If we talk to our maintenance people and tell them, hey, listen, you can upgrade your PCs while the process is still running, they get this gleaming shine in their eyes and, well, really? I don't have to come in on Sundays anymore to do that? Because you just shift the compute load away from this one PC you're going to upgrade to the others. You upgrade the one, and once it's back up, you shift the compute loads back. So all of a sudden, you can do updates while the processes are running. So this is the vision. We're not there yet. But this is the route we're taking because we think this is going to be the future. And why do we do this? For the maintenance costs we have right now in our factories. As I said, 45,000 PCs. And now imagine you want to do an operating system upgrade on 45,000 PCs, which you cannot do remotely because every single one of them has a specific task. You have to walk to that PC, you have to do the upgrade, you have to pray that the drivers still work for that specific task, and then walk on to the next PC. It's an incredible amount of money we're spending on doing these operating system upgrades, and those operating system upgrades won't go away. So it's no use in shutting your eyes and praying nothing will happen if I don't do this upgrade. No, this is the wrong approach. We have to think of how to do this better, and this is our solution. And for our assembly lines where we have less automation, therefore less compute power need, a setup would probably look like on the right-hand side where you have one industrial PC operating a complete assembly line, because in a complete assembly line there are only 3 to 4 automated stations, the gluing, the adding of the windshield and stuff like that. So we can do the same thing on the assembly lines. And in the end, we hope that by going down this road, we will actually really save a lot of maintenance costs, get the security much better than we can do this today, and have a much better understanding of what's happening on our shop floor. That's on the one side. And on the other side, by being able to provide general compute where you need it latency-wise, we can deploy algorithms, we can deploy AI functionality. And this is a short sketch. You have this function layer, you do everything in there that you need for the purpose, for the functions that you want to do. And so there are still quite a few problems to solve before we can do this. If you want to virtualize a PLC and have it run on a function layer, how about human safety? How do you ensure that through this stack, the hardware layer, the software virtualization layer, the function layer gets the signals in time so that the PLC reacts in the required amount of time so this whole setup can be human safe? Yes, we're not there yet, but that's something I think we need to work on, and we need to work on getting this software layer, this virtualization layer, that's our belief, as an open standard, so that everybody who wants to develop services, who wants to develop functions to operate on that, can just adhere to that open standard and can do that, so that at the end, we are a car producer. We just heard from the colleague from the Bank of America, we should shift into becoming software producers. Still, we are a car producer. Other parts of our company will become software producers, probably in the future, but building a car will be a craftsmanship. It's something to produce, to work, and therefore we won't be programming all those functions. We want to buy them, but we want to buy them in a way that they work with this architecture, that we're able to take the best functionality, the best algorithm we need for our process and have it run in this function layer. So this is the small insight I wanted to give you today on the route that we are taking. We're taking as Audi and as a VW group in order to go a new step, a next step for me in automation, changing the paradigms of automation that have been valid for quite a few decades, and now go the next step and do something new. Thank you for your attention.